Okay, secant theta to the 5th power, right? Secant to the 5th. So I'm going to have whatever secant is to the 5th. The reason I put a big parenthesis is because secant is the reciprocal of cosine. So I know I'm going to have a ratio. I'm going to have a fraction there, right? Cosine is this over this, right? Cosine is this over this, so secant is that over that. Hypotenuse over adjacent. So I'm going to take the square root of x squared plus 4 all over 2. And then minus 1/3, same thing, same expression, but this time cubed. Square root of x squared plus 4, and then all over 2 as well. Plus c, yes, thank you. All right, let's see if we can do something here. I'm done. Okay, that box that up, we're done, but just for fun, let's do this. X squared plus 4 to the 5 halves over, so what I'm doing here is I'm putting the 5th power on this, right, which means this. And what's 2 to the 5th power? 2 to the 5th? What do we got? 2 times 2? 32. Times 2? It's 32, okay, 32. And then minus 1/3, and then this right here will be x squared plus 4, this time to the 3 halves power, and then over 2 to the 3rd, which is 8, plus c. And now I'm going to just multiply this 32 through. Do you see what happens if I go here to here? Do you see it'll cancel with that? Okay, so I'm going to try and get a final answer here. It'll be 1/5 x squared plus 4 to the 3 halves, to the 5 halves. And then what happens when my 32 comes here? 32 is here. What's 32 divided by 8? 4, so this is 4/3. Okay, so minus 4/3. And then x squared plus 4 raised to the 3 halves plus c. That's actually not a bad looking answer, right? I just wanted y'all to see how that cleans up. Now I'm going to try and see if the computer actually works this time. Let's go to Wolfram Alpha, see if it works. I'm going to integrate, I forgot the problem, there it is, x cubed, and then it was square root of x squared plus 4 dx. And I'll make that a little bigger so you can see it. Okay. I'm okay with that, I think. What they did to see that answer, do y'all see it or not? Get a common denominator between these. 15? So you'd have to multiply this by 3 on top. And then 15 here, you'd have to multiply bottom by 5. And I think you get, wait, hold on. Is that right? Yeah. And what do we get here? 20? That doesn't look right now. Well, we have to actually do it. So what did they do? They pulled out a 1 over 15, and they pulled out an x squared plus 4 to the 3 halves power. And if I do that, what am I left with here? See, they realize you have x squared plus 4 to the 3 halves and to the 5 halves, so they both have a 3 halves in common. If I pull that here, I'll be left with what? A 3, and then x squared plus 4 to what power? Well, if you take away 3 halves from this, you're left with 2 halves, which is 1. So it's just that. And then minus over here, you pulled out the 15 on the bottom, so you just have a 20 there. And then that whole thing went away. And then let's distribute 3x squared plus 12 minus 20. And that's 3x squared minus 8. So it matches. I'm just saying, it is right. So you can, like I said, you can really tell, right, when a computer does it versus when a human does it. Like, we're ready to stop like right here, right? We're ready to stop right here. Maybe we do this step, maybe we get to here, but we usually aren't going to say now factor. There's no need for us to do this. There's absolutely no need for us to do that. But the computer is just programmed to just, oh, factor if you can, you know? All right, how y'all feeling? All right, so far? Did everybody get one of those worksheets from last time over this? Is anyone missing the worksheet? Okay, I don't know if I have any. I don't know if I have any with me, but okay. Oh, by the way, here are the quizzes. I was waiting for people to show up because there's a little. There are no grades on those, so don't worry about people seeing your grades. And hey, let me tell you something about these quizzes, right? I'm going to drop at least probably 2 because I'm going to have enough quizzes to drop 2. Look, if you don't do well on a quiz, right? Like, I get it. It can be discouraging, but at the same time, I told you, you're going to get a lot of things wrong before you start to get to the level that you're comfortable and you get things right all the time. So, I'd rather you struggle a little bit on the quiz and continue to be motivated. Like, what I'm saying is don't lose hope, okay? If you do bad on a quiz. But you got to keep putting in effort. You got to keep putting in the time, practice, and hopefully it'll come together at the exam. All right, I have a somewhat different problem for you to look at real quick. All right, so the problem is this. Oops, yeah, this is under a square root, sorry. So we have 1 over the square root of, and then in parentheses, x plus 1/3, that quantity is squared, and then minus 9. So what I want you to see here is that doesn't look exactly like one of those forms. I mean, it's almost, right? Do y'all see it's almost the form that we need? Which one is it? Why is this so laggy? Weird. Does it look like the third one to you? Yeah, everyone see that? This kind of looks like the third one. Like there it says x squared minus a squared underneath the root. Here we have a root. This isn't quite x squared, is it? But do y'all see that this is a linear expression? And whenever we have linear expressions like that, we can just do a basic u sub to start the problem. Let's just do a basic u sub. A basic u sub of u is equal to that linear expression. What's the derivative of that? 1 dx, right? Do you see a 1 dx there? Yeah. Okay, so rewrite the problem. What would this turn into? Integral 1 over square root. You replace the x plus 1/3. You replaced it with u, so that's just u squared minus 9, and then dx is being replaced with du, right? Do you see that? Just a basic u sub. Now that looks more like that, doesn't it? Except instead of x, we have u. So it's a different variable, but we could use the same trig sub, couldn't we? We could use a same trig sub. What trig sub would I use here? What is equal to secant? U. So I'm going to go trig sub. I'm going to do trig sub here. Okay. I'm going to let, well, what's a first? A is 3, right? Okay. I'm going to let u be equal to, not x, right? U is going to be equal to the third one, right? A, 3, secant theta. Are y'all with me here? Yes?
It doesn't matter if it's a negative on the A.
If it's a negative on the A. What do you mean?
Like minus 9?
No, because in the formula, the minus you're ignoring, and that is a squared.
Okay.
So if that's a squared, what's a? It's 3.
Okay.
Okay? All right, now differentiate this, right? I'm going to say du equals 3 comes for the ride, derivative of secant x is secant theta is secant theta, tangent theta, d theta. And the square root of u squared minus 9 would be what? Yep. Square root of, okay, square the u. So 9 secant squared theta, right? Then minus 9. And then you factor out a 9 and use your Pythagorean identity. Secant squared theta minus 1 is tangent squared theta. And so we get 3 tan theta. We've already done one like this already today, right? I really wanted you to see that first step, but let's continue. I want to finish the problem. This integral now becomes, so I'm talking about this one right here, 1 over what? 3 tan theta times du, which is this right here. Good. So integral 1 over the root part, which is 3 tan theta, and then the du, which is the 3 secant theta, tangent theta. Ooh, that's nice. D theta, I think it's nice. Am I happy about that or not? Are you happy about that? And all you get is integral secant theta d theta, right? And this was that one that I told you someone like sat and tried to figure out for a long time, finally figured it out, and I would never expect you to figure that out, right? But I told you there's a formula for it, right? The antiderivative of secant theta is natural log secant theta plus tangent theta, right? Plus c. Y'all finding that formula? We did it in class. Okay, so this to here, I'm going straight to the formula sheets. Can somebody tell me what formula that is? 14? Remember, you're allowed to use that formula sheet, right? So formula 14. Okay, we've got that. And now we need to figure out what secant theta is, and we need to figure out what tangent theta is, right? So that means I'm going to need a reference triangle. I'll do my reference triangle over here. When I do my reference triangle, what am I basing it off of? My trig sub, right? This. So that's the same as saying u over 3 is secant theta, right? Dividing both sides by 3. And then my triangle looks like the following. Here's theta. And secant is the reciprocal of cosine. So shouldn't this be u here and 3 here? Yeah, that's what secant is. And then this side has to turn into the u squared minus 9. All right, continuing this, equals natural log absolute value, secant theta, u over 3, plus tangent theta, square root of u squared minus 9 over 3, plus c. You could put these together because they already have a common denominator, couldn't you? But I'm just going to leave it like that. Or maybe I will, because I need to get it back to x still, don't I? So maybe I do put them together. Any questions? Any questions? All right, I just erased what I needed. What was u? X plus 1/3, right? X plus 1/3. So this is going to become natural log absolute value x plus 1/3 over 3 plus square root of x plus 1/3 squared minus 9 all over 3, close the absolute value, plus c. There we go. That's your final answer right there. Good? What are y'all thinking over there? Look at that. Oh, that's terrible. What are you seeing here? Does it look like that? No, right? This does not look like that. Because in all of those, you have a number squared, right? You could argue that number is what? That's the square root of 8 squared? And you could argue with me that that is like the x squared, kind of. But none of those have a middle term like that, do they? None of them do. So right now, we don't have a method for this, do we? Like these formulas do not work, or don't appear to work for this. Do you all see that? Okay, so what are we going to do? Well, let me show you. All right, let me show you what we're going to do. We're going to wind up using one of those formulas, but we got to do a lot of work before we can use it. So you ready for this? I'm going to stop the problem for a moment. And I'm going to take this 9x squared plus 6x minus 8, and I'm going to complete the square. Tell me how you really feel. I'm going to complete the square. Okay, everybody here has learned how to complete the square, hopefully at some point, and everybody has learned it a different way. So the way that I'm going to show it to you might look different than the way that you learned it, and trust me, you need to learn it this way because, well, you'll see. Let's just see how this goes. Let's see if y'all even remember how to complete the square, all right? So does anyone remember what I've got to do first before I even start completing the square? Divide something. This right here has to be a 1. In order for completing the square to work, that must be a 1. All right? And it's not, right? But see, I don't have an equation right now. What I'm dealing with is an expression. So I can't divide both sides by 9 because I don't have both sides. I only have an expression, right? So instead of dividing by 9, I'm going to factor 9 out of everything. And there doesn't look like I can factor 9 out, but I can. So I pull a 9 out. That will leave me with x squared, right? Of course, 9 times x squared would be 9x squared. Here, though, I don't have a 9, do I, to factor out. So what I'm going to do is put 6 over 9x. Now that's because that it works, right? Look, if I distribute a 9 right here, what happens? The 9's cancel, I get 6x, right? And then minus over here, I'm going to pull out a 9, so I'm going to have to put it 8 over 9, minus 8 over 9. Same principle. If I multiply through by 9, it's going to give me minus 8, right? So I've factored a 9 out. Any questions there? Okay, let me clean it up a little bit because that fraction reduces. So I'm going to have 9, and then I have x squared plus, this reduces to become 2/3 x minus 8/9. Okay. That's the first thing. In order to complete the square, you must have a 1 in front of this. So this 9 right now is just going to hang out with us for the rest of the time. But I'm focusing all my attention on what's on the inside. So once you have a 1 in front, what's the next step? Let's see if anyone remembers the next step. Y'all think about it. I can go get a couple of more blue markers. There's this technique that we use here. Did you all remember it or talk about it? No?
Do you move the constant?
Which one?
8 and negative 8 on the head?
You move it where?
You would add it, but onto.
The other side,
Yeah.
which doesn't exist. See, this is the whole point. A lot of us, when we learn completing the square, we learn it when we're trying to solve a quadratic equation. So you have two sides to work with here, right? We don't have two sides, okay? That's why you need to learn this way. It's when I teach completing the square, I don't do equations. I just do expressions, because when you get to Cal 2, you need to be able to do it without an equation. Yeah, okay, so what's the technique? We take the number, the coefficient, after we make sure that this is a 1, we take the number in front of the x term, okay? What do we do with it? Divide it by 2. Divide it by 2. Or multiply it by a half, however you want to say. This is just part of the technique for completing the square. I'm going to take that number 2/3, and I'm going to divide it by 2, right? Which is the same as taking 2/3 and multiplying by the reciprocal of 2, which is a half. And what does that become? 2/6, which is 1/3. Okay, the 2's cancel. All right, so completing the square, I'm going to just revisit this with you. You have this quadratic. You make sure that the leading coefficient is a 1. Once you've done that, you take the number in front of the x term, the coefficient of the x term. You take it. If it was negative, I'd put negative 2/3 here, but it's positive. So I put 2/3 here. I always will divide it by 2. Why? That's the technique, okay? Divide it by 2, which is the same as multiplying by a half. You get this number 1/3, okay? I'm going to put a little box around it. That's my first kind of important number, all right? Now, what I'm going to do is take that 1/3 and square it, completing the square. This is us doing the process. So now I take that 1/3 that I just got, and I square it, and 1/3 squared is 1/9. That's kind of like my second important number. Does this look familiar a little bit? Okay, what do I do with the 1/9? Well, if you were back in class when they were doing it with equations, you would add 1/9 to both sides of the equation. The problem is, again, we don't have an equation. So I can't add 1/9 to both sides. So instead what I'm going to do, I don't have my red. Where's my red? I don't have red. Is there a red marker around there? Throw me one of those red markers. Oh, good one. Looking like. Okay, so what I'm going to do here is I'm going to do something that happens in math, okay, that is really an important part of math, and that is this. Let me rewrite it. 9, I have x squared, right? I have plus 2/3 x, and then right after that 2/3 x, right after it, everyone's going to realize that there's a plus 0 right there, and then minus 8/9. See, remember, I'm not allowed to add something to both sides of the equation because I have no equation. So what I'm going to do is I'm going to realize that right here there's a plus 0. That's true, right? It's weird, but it's true. And then what I'm going to do is I'm going to write that 0 this way. I'm going to take that number 1/9. I'm going to add the 1/9 and simultaneously subtract the 1/9. And that is still 0, isn't it? And then I have minus 8/9 over here still. That is not a very natural thing to do, but this is how you complete the square when you don't have an equation. Y'all good still? I mean, when you do this, okay, and by the way, you have to do plus then minus, not minus then plus for this to work. It's got to be the plus of this. This will always be a positive number, right? Because you're squaring something to get it. So I add it and subtract it. So once you've done this step, the whole purpose of this is that these three terms are now guaranteed to be a perfect square trinomial. In other words, what I'm saying is that this, hold on, let me just rewrite all this. All this is still here. All that's still there. But these three terms factor to be x and then some number here squared. Do y'all know what that number is in here? It's plus 1/3. And guess where you can get that from? This number right here. That's plus 1/3, right? That's positive 1/3. So if I put plus 1/3 here, plus 1/3. Now, if you don't believe me, I'm going to prove it to you that this is this. I'm just going to prove it to you, in case you're skeptical. If you take x plus 1/3 and you square it, you're going to multiply it times itself like that, right? And now if I FOIL this, or expand it, I get x squared. Here to here I get plus 1/3 x squared. Here to here I get another 1/3 x squared. And then here to here I get a plus 1/9. And when I put those two together, I get 2/3 x. And so I have x squared plus 2/3 x plus 1/9. That's going to happen every time. Okay, you know, good? So I continue. These two come together now. What's negative 1/9 minus 8/9? Yeah, minus 1, right? Minus 9/9. That's minus 1. Isn't that nice? That worked out nice. So we have 9, parenthesis, x plus 1/3 squared minus 1, close parenthesis. One more step. I'm going to distribute the 9 through here and here to get rid of those parentheses. When I multiply the 9 through here, it cannot go into this parenthesis, right? Because you have a squared. So it's just going to sit out front. So it's going to look like this. Oh, perfect. I'll put it right here. It'll be a 9 sitting in front of x plus 1/3 squared. And then minus what? 9. That's what that is. This is equal to this. We have completed the square. We have said that this quadratic expression can be rewritten like this. Yeah? Okay, let's get back to the problem. So this can be rewritten as integral 1 over the square root of, and instead of that, I can have this there, can't I? I can have 9 x plus 1/3 squared minus 9 dx. That's because I just completed the square. And do y'all see that 9 that we just passed through to both of these? Do y'all see that 9 that we just pushed back through? Do y'all see we can take it back out? And if we take the 9 back out, what can we do? We can square root it and pull it on the outside of the root as a what? It's a 3. And then it'll come out as a 1/3, right? So I'm going to do that. I'll show the step just to make sure I don't lose anyone at this step right here. So I'm doing 1 over, I've kind of changed my mind, and that 9 that I had pushed through, I kind of want to put it back out here. See, I pull that 9 out. Now there's multiplication. When there's multiplication, I can take the square root of each one. The square root of 9 is 3. So I have a 3 on the bottom, comes out as a 1/3 integral 1 over the square root of x plus 1/3 squared minus 1 dx. Yeah? Now, what? Yeah, so what? Look at the problem we just did right before this one. What was it? What did I give you? It was this, but this was a what? I think this was a 9, right? Here it's a 1. So you go through the exact same steps as the previous problem, except A is 1 here. This will be a little bit easier. Yeah? Dot, dot. I'm not doing the rest of it. You get what I would do, though, right? Okay. So now we have this new wrinkle in everything, right? That if you have a quadratic under a root, you can always complete the square and turn it into one of those forms. All right? We're going to do another one. Okay. This will be our last one. Yeah, maybe. Yeah, I guess so. 5 plus 4x minus x squared. So I've given you a quadratic underneath there again. So you can't use one of the trig subs right off the bat, can you? Nope. But we can complete the square, can't we? And if we complete the square, the first step of completing the square is to make sure that we have a 1 in front of the x squared, right? So here I go to complete the square. Let me write down the quadratic first. Crap, there's a negative there, right? It's okay. I can rewrite it like this. Oh. That's just me rearranging, right? That's just me rearranging. And now that must be a positive 1. So I'm going to pull a negative 1 out. Yes?
I thought you said we couldn't pull out negatives for, oh, wait, okay.
Yeah, I haven't pulled it out of the root, right? I'm just completing the square, but I'm glad you're seeing that because that is going to present a problem for us in a minute, all right? Because I'm not going to be able to pull the negative 1 out. Can't pull a negative out of a root. But let's continue. All right, so I take now the number that's in front of x, negative 4, right? I take half of it. So I take that negative 4, I take half of it. I just grabbed this marker. I'm convinced that they just come take all our dead ones and put them back in the office for us to reuse. Okay, so I take negative 4, I divide it by 2, I get negative 2. That's the first number that's going to be important. And then I take that number and I square it, and that gives me 4. That's my second important number. That's the one. The second one is the one that I'm going to be doing the plus and the minus. I'm going to add it and subtract it. I'm going to have that hidden 0. Where does the hidden 0 go? Right after the minus 4x, right? Right after the minus 4x. Here's my plus 0. And I'm going to rewrite that plus 0 as what? Plus 4 minus 4, right? Not minus 4 plus 4. Plus 4 minus 4. And then I still had the minus 5 there, right?
So is all of that equal to 0?
Is all of what equal to 0?
Like the...
No, I'm not setting it equal to 0. I'm not sure I understand the question.